Here is an explanation for the answer to final exam, question number 72, in Alternative Energy Demystified, 2nd edition. If you have the printed book, please see page 326. We're talking here about changing a certain amount of liquid matter to its gaseous or vapor state by adding heat energy to it. What do we call that amount of energy, or how do we express that amount of energy? For example, if we have 1 gram of water, it'll take a certain amount of energy to convert 1 gram of liquid water to 1 gram of vaporized water. That turns out to be about 540 calories at standard atmospheric pressure at sea level. It takes a certain amount of energy then to change a sample of liquid to its gaseous state, assuming that the matter can exist in either of those two states. Scientists express this as what? The answer is the heat of vaporization. The heat of vaporization. The condensation coefficient, well, if we were cooling it down, we might use a term like that. But I've never heard of condensation coefficient. Coefficient of performance, well, that has to do with heat pumps or heat exchangers, as they're called. But that is not directly involved with this situation. Vaporization point, well, for water, we might call the vaporization point the same thing as the boiling point, or plus 100 degrees Celsius at standard atmospheric pressure at sea level. The heat of vaporization is the answer once again. Energy conversion coefficient, I've never heard of a term exactly like that. But anyway, we're not converting energy here. We're converting the state of the matter. Let's take a look at a graph of what actually happens with water when we add energy to it or we take heat energy away from it. Here we have liquid water that we're heating up, plus 70, plus 80, plus 90 degrees Celsius. It reaches the boiling point, and then the temperature stalls or levels off at this boiling point. Once again, plus 100 degrees Celsius would be at standard atmospheric pressure at sea level. Once that water has turned entirely into vapor, then the temperature can continue to rise if we continue to add heat energy to it. Conversely, if we reverse that process, we take vaporized water and we take heat energy away from it, we can cool it down until it gets to that critical point once again, and then it will stall out at that temperature until it is all turned to liquid, that is all condensed. And then if we continue to take heat energy away, it will continue to cool down. This amount of energy to get from this point to this point, or from this point to this point, is the same for any given quantity of a substance under the same conditions. So, for example, if we take a gram of liquid water, it takes 540 calories of energy to get from here to here at standard atmospheric pressure at sea level. Similarly, 1 gram of vaporized water, it takes 540 calories that we have to take away from it to get from that point to that point, and then it will continue to cool down if we continue to take heat away. But anyway, therefore, for the case of water, we have 540 calories per gram. That 540 calories per gram is known as the heat of vaporization of water. So, once again, the correct choice for this question is choice D. Choice D as in Delta, for those of you who like phonetics.